Alright, let's start part A. This will be an implicit differentiation of a problem given. So they ask you to find show that dy dx is equivalent to this, so it means that we need to do the ddx of this, the left side and also right side. You get 2x minus 8 y minus 8. I'll do this. Okay, 8x dy dx plus 2y dy dx. In case you have forgotten the implicit differentiation, please do your best to review this. And so I'm going to rearrange this. Okay, and you have 2y minus 8x, and here you have 8y minus 2x, and I'm going to multiply across by half because there's a common factor of 2 times half. You get this. And so finally, of course I can then multiply by -1, the numerator denominator, and I'll get x minus 4y, which is something well required of us. This is shown. Okay, now to find the equation of tangent, first we need to find the slope. So at point 2, -2 given to you, and the slope is dy dx, and all you need to do, just substitute. And this is actually 10, and this is also 10, and this is 1. And so the equation of tangent is this one, y minus y1 or x minus x1 equal to m, and that is a y minus -2, x minus 2 equal to 1. So we have this equals to x minus 4 after you simplified it. Alright, now moving on to the next one. Alright, this part C. It asks you to check whether the tangent meets the curve again. Now how do we do that? I can think of a way, because we have the equation of tangent from B just now, and also we actually given this guy here from the original questions. So all we need to do is solve this simultaneously and see whether there are more values of x or y, what have you. So I'm going to sub 1 into 2, and I should get something like this. Make sure you span carefully. Okay, here you have positive x squared, negative 8x squared, and so the outcome of this would be a negative 6x squared of this tree here, and 32. Oh, I missed something here. It's the 2x. So 32x and 8x, I get plus 24x, and 16 minus 40. This is negative 24. And I times -1/6 across, because the common factor of 6, as you can see. And I don't like negative here in front, so I get times -2. So I get 4x plus 4, and actually I can factorize this. If you think about it, this is in fact square of x minus 2, and so if you solve this, you get repeated roots, and that means only one thing, and this in fact is the point given earlier to you, at the point 2, 2. So this is the only point where the point of contact between the curve and also the tangent, and there's no other point. So therefore you can then argue that from here this is a repeated roots, and so there is no other point of contact. Actually, in other words, we're saying that the tangent does not meet the curve again, and of course, so in that case we do not have to find the coordinate of the non-existent point, because there's no such point. The only point is 2, -2 given earlier. And lastly, let's just show that the curve has no horizontal tangents. And how do we do that? So we're going to employ something in mathematics, very popular approach, proving by contradictions. Well, how do we do contradictions? It's something like this. And suppose we have given a dog, all right, and someone say the dog can actually fly, okay, and how do we show that that's not true? So what we do is we start by assuming that, okay, the dog can fly, and then we show that by saying that statement, making that statement that dog can fly, there are a lot of impossibilities, a lot of things go wrong, and therefore because of those contradictions, and then it means that our initial statement, a proposition that the dog can fly, must have been wrong, and then they must be, then it's wrong, it's not true, so dog can't fly. Okay, so right, that's not a good analogy, but well, the idea is this. So first we start by this suppose now we ain't asked to show that there's no horizontal tangents, and horizontal tangents occurs, and when that's the case, we know that dy dx is 0. But we asked to show that the curve has no such tangents, so this can't happen, right? Think about it, right? You can't have a tangent where its slope is 0, because there is no horizontal tangent. So what we do is suppose that dy dx is indeed 0. We will show that because by making this statement, there will be, well, something wrong at the end. So okay, dy dx 0. We shown earlier that dy dx is this guy here, and so looking at the numerator, we have x equals to 4y. Okay, and so now what we're going to do is we sub x equals to 4y into equation 2, this one, the equation 2. Okay, and so so we have 4y square minus 8, 4y, y plus y square equal to 40, and you have 16y square. This is 32y square plus y square is equal to 40, and then do the calculation. This is negative 15y square equal to 40, and the y square is equal to negative 40 over 15. I'm not going to simplify, but this is already proof enough to show that to argue that this statement is wrong, because this is impossible, right? You can't, y square can never ever be a negative. So what we're trying to say is this: there is, if this is the case, it means for y there's no real solution. This can't happen. Y squared must always be positive, and we see a negative here. So that means that something possible does happen, and this is due to the fact that we started out with this statement. Then the only explanation must be this statement is not true. We suppose that this is true, but we got this crazy things here. So this must be because this is not true, and therefore dy dx cannot be 0, and this supports our claim that the curve has no horizontal tangent. Alright, so hope you try similar questions later, and all the best.